In my previous video, I introduced what I'm calling the Gaian timescale. In this perspective, each yearly cycle around the sun is imagined to be one heartbeat, and time is compressed so that 80 years, the duration of a typical human lifespan, pass every minute. We learned that all of recorded history can fit within the last hour of Gaia's life, and a variety of milestones of human development occurred over the last 12 hours. But to find the origins of our species, we're going to need to go back much further. First, let's take a look at just the previous Gaian week to gain our bearings. This global climate record, derived from oxygen isotope measurements of deep-sea sediment cores, covers the last week of Gaia's history. At 24 hours ago, one full Gaian day, we have the beginning of the last glacial period. Before that was another brief warm period, the Eemian interglacial. Glacial periods, and the interglacials that separate them, can vary in duration, of course. But thinking of them as cycling like days and nights in Gaia's life isn't such a bad analogy for understanding the climate variations of the Pleistocene epoch, which directly precedes our current Holocene epoch, the name we give the ongoing warm period since the end of the last major glaciation. Let's extend this temperature record back to a full month of Gaia's history. That's about 3.5 million years to us. The Pleistocene epoch, which together with the current Holocene epoch forms the Quaternary geologic period, started just over 3 weeks ago. Now we can see how, over the course of the Pleistocene, the frequency at which glacials and interglacials alternate has gotten slower, but the glacial periods themselves have also gotten colder. This whole sequence is what is colloquially known as the Ice Age, or more formally, the Quaternary glaciations, defined by the presence of large amounts of land-based ice. In other words, ice sheets, varying in geographical extent over the course of the glacial cycles, but never fully disappearing. A bunch of other interesting things happened in the last month of Gaia's time, which also roughly corresponds to the time period known by anthropologists and archaeologists as the Paleolithic, or Old Stone Age. And for good reason. Around 29 Gaian days ago, the first stone tools show up in the archaeological record, likely employed by our predecessor group of hominins, the Australopithecines. 25 days ago, the Greenland ice sheet begins to form, setting the stage for the glaciations of the Pleistocene to come. Antarctica had already been iced over for several Gaian months at this point. 23 days ago, the formation of the Panama Isthmus allows animal species to cross between North and South America for the first time, resulting in the Great American Interchange. 22 to 21 days ago, the first members of our genus Homo appear in Africa, and stone tool use becomes more widespread, with the Oldowan stone tools associated in particular with Homo habilis. This technology is replaced by the more sophisticated Acheulean stone hand axes and cleavers associated with Homo erectus around 15 days ago, and further refined by attaching stone points to spear shafts around 4 to 5 days ago by the common ancestor of both Neanderthals and modern humans, conventionally called Homo heidelbergensis. In parallel, around 8 or 9 days ago, we have the earliest clear evidence for the controlled use of fire, though it doesn't become widespread until around 3 or 4 days ago. Finally, around 2.5 days ago, we have the earliest appearance of anatomically modern humans, or Homo sapiens. Though other hominin species had previously migrated out of Africa in waves starting as early as 18 days ago, for us Homo sapiens, any attempts to expand beyond our home continent seem to have been relatively unsuccessful until well within the last day or so, when we started venturing out from eastern Africa along the coastlines and eventually worked our way inland to cover Eurasia and Australia over the course of the next few hours. It's been a busy month for our hominin ancestors, but in evolutionary terms, we have to go back even further to uncover our relationships with other non-human animal species. 2 Gaian months ago is roughly the time of the last common ancestor of humans and chimpanzees, who likely also lived in Africa. This lineage probably split off from the lineage leading to gorillas around a month or so earlier than that. This means that not only are chimpanzees, including bonobos, our closest living non-human relatives, but also vice versa. Humans are the closest living species to the chimpanzee bonobo genus Pan, since they're more closely related to us than they are to gorillas. The last common ancestor of all great apes, not only the so-called African apes comprising humans, chimpanzees, and gorillas, but also orangutans, lived around 4 or 5 months ago, and the last common ancestor of all the apes, including gibbons, lived somewhere between 5 and 6 months ago. All of this occurred over the course of the Miocene, the geologic epoch immediately preceding the Pliocene and Pleistocene mentioned earlier, lasting from around 6.5 months ago to 1.5 months ago. So that's what can happen in just a few months on Gaia's scale. At 80 years a minute, all of recorded history took place within the last hour. All of the last glacial period, including modern humanity's expansion out of Africa and subsequent cultural development all around the world, occurred within the last day. The story of our recent hominin ancestors in the Paleolithic covers just the last month, and the entire evolutionary descent from the last common ancestor with all our fellow apes happened within the last 6 months, just the last 2 of which differentiate us from chimpanzees and bonobos. But we're not going to stop there. What can happen over the course of years on Gaia's timeline? That's going to be the topic of my next video.